Hello, let's talk about adding mixed numbers with no regrouping. So I want to do two problems, one with easier denominators and one with hard denominators. So the first one we're going to look at is 4 3/10 plus 5 1/8. Now, we know how to do this part, all right, the 4 and the 5, that's old stuff. We've also been talking about this part this year, right? So we're just going to treat them as two separate problems. All right, so one will just add the 4 and the 5, and the other will add the 3/10 and the 1/8. Let's do the 4 and the 5 first because that is way easier. All right, so that's just going to give us 9. Now this part we need to do some thinking here because we have to find a common denominator for the 8 and the 10. And again, these are smaller denominators, so I would say it's very practical in this case to just skip count by tens to see if we can find out what multiple of 10 is also a multiple of 8. So if we've got 10, 20, 30, 40, up there it is. 8 goes into 45 times and 10 goes into 44 times. So that is our common denominator. All right, again, we're going to do times 4 here. And again, we always have to make this a 1, a whole, because otherwise I'm changing the value of the 3/10. All right, so it's got to be 4 over 4. And then here we just said that 8 goes into 45 times, so this is going to be times 5. All right, so then we've got 12 for the numerator here. I put this way too close. And then we've got 5 over 40. Again, 1 times 5 is 5, 8 times 5 is 40. And now we just add them. All right, so again, 12 40ths plus 5 40ths. This is like 12 puppies plus 5 puppies. We just add the numerators. That tells us how many we have, and the 40ths tells us what we have. Right, so this ends up giving us 17 40ths. And so our answer is the combination of the two of them. So this would be I was almost ready to say 19. 9 and 17 40ths. Now we just smush them together like this, but in reality it's really 9 and 17 40ths. We just don't bother to write the plus sign in it. We write it this way as a mixed number. But when we say it, we say 9 and, for that imaginary plus sign or that implied plus sign there, 17 40ths. All right, 9 and 17 40ths. Oh, and I forgot to say we should check to make sure that these don't reduce, the 17 and the 40. We could say here 17 is a prime, and so the only way they're going to reduce is if 40 also has a 17 in it as a factor, but it doesn't. 17 times 2 gives us 34, and another 17 is going to skip right over 40 and be too high. All right, let's do another one of these. Okay, and so let me also say this. No regrouping, what that means is that if we end up with something here that was larger than 40 40ths or equal to 40 40ths, we would have to turn this into an improper fraction. So when we say no regrouping, what we mean is that this fraction, when we add these two, we get a proper fraction, and therefore our answer is just complete here as long as we've reduced this. All right, so in another video, we'll talk about what to do if this gets to be an improper fraction and we do have to regroup. All right, so the second problem I want to do with you is one with harder denominators, just so we get practice with that. So it's 3 and 5 24ths plus 6 and 7 36ths. And again, this is two, basically we can think of it as two problems. How we would add 3 and 6, again, totally old school stuff. And then how we would add 5 24ths and 7 36ths. This is the newer part. So let's just do the older part, the 3 plus the 6. Oh, 9 again, I didn't mean for that to happen, but and then we have to talk about adding these two. Again, I don't know my multiples of 24 very far. I don't know my multiples of 36 very far. So for me to try and list like I did right here, A, would take a long time, and B, I don't even know if I would recognize when I got to a multiple of 24. So what we're going to do is instead we're going to do prime factorization for each of them. So 24 can be written as 4 times 6, and then 4 can be written as 2 times 2, and 6 is 2 times 3. So we end up with 3 2's and 1 3. And then 36 is 6 times 6. Again, you might have thought of 3 times 12 or 4 times 9. It doesn't matter. You'll get to the same thing at the end. 2 times 3, 2 times 3. All right, so when we write out our prime factorization, again, we're going to stack them up like this. So 24 is 3 2's and 1 3. Since there's more 2's there, I'm going to start with that one. 3 2's and 1 3. And then I'm going to write 36, which is 2 2's and 2 3's. So I'm going to do 2 2's and 2 3's. Again, it doesn't matter where you put them as long as you line them up, all right, so that common factors are over common factors. All right, now we're going to go through and we're going to circle the ones that they have in common. And we're going to bring them down. All right, so we're going to have a 2, a second 2, and then a 3. And then I bring down whatever they do not have in common. All right, so another 2 and another 3. And that is the least common multiple. All right, again, let's multiply it out. So I know just from above here that 3 2's times 1 3 is 24. And then I've got that 3. So our LCM is going to be 24 times 3. That is, put down the 2, carry the 1, 6, 72. So 72 is our least common denominator. So we're going to get ready here. This actually wasn't as hard as some of the other ones that we've done because these both have a 12 in common and therefore it just would have taken us up to our 6 times 12s. Okay, so then I need to say, well, how many times does 24 go into 72? Again, we're not going to divide to do this. We're going to look down here and we're going to say, what did 24, which was 2 times 2 times 2 times 3, contribute to the least common multiple, or again, least common denominator, because we're talking about fractions now. So it contributed these 4 things, the 3 2's and the 3. So what did it not contribute? It did not contribute this extra 3. And therefore, 24 is missing a 3 to be exactly the way a 72 is. And so we're just going to put that as 3 times 3/3. Right, then we do the same thing for 36. 36 contributed 2 2's and 2 3's. That's this part right here. What did it not contribute? It did not contribute this 2. Therefore, we have to go here, 2 and 2. Okay, then we end up with 15 as our numerator here, and 14 as our numerator here, and then we add them. So 15 and 14 is 29, 29 70-seconds, or 29 over 72. Right, then we have to check to make sure that this does not reduce. And again, I recognize this 29 as a prime, and so all we would have to do is see, is 29 a factor of 72? Well, we know it's not because we just wrote all the factors of 72 right here, and 29 was not one of them. And so this is fully reduced. And so our answer is 9 and 29 70-seconds. Final answer. Okay, hope that helps.